Lesson 21: Preserving and Resetting State. 1. Introduction. State in React is isolated between components. React keeps track of which piece of state belongs to which component based on its place in the user interface tree. You can actually control when React should preserve a component's state and when it should reset it, depending on how components are rendered over time. 2. State is tied to a position in the render tree. React builds an internal render tree that represents your component structure. When you give a component its own state, it might seem like that state lives inside the component itself. But technically, it's stored by React, which links each piece of state to a specific position in the render tree. If two components appear in different positions in that tree, React treats them as separate instances, even if they are created from the same component function. This is why, when you have two counters rendered side by side, each one has its own independent state. They don't affect one another because React treats them as distinct, isolated entities. 3. Preserving state while rendering. React keeps the state of a component as long as it continues to exist in the same position in the render tree. If you remove a component, React destroys its state completely, and when you render it again, a brand new instance is created with fresh, initial state. This behavior becomes very clear when you dynamically add or remove components, for example, toggling a checkbox to show or hide something. Each time a component disappears, its state vanishes too. 4. Same component at the same position preserves state. If the same component stays in the same position, React keeps its state intact, even if you change its props or visual style. From React's perspective, it's still the same slot in the tree. For example, toggling between a fancy or non-fancy version of the same counter doesn't reset the score. The structure of the tree remains the same, so React keeps the internal state. A common mistake is to assume that state depends on your conditional logic or markup, but it doesn't. React doesn't care where your conditions are in the function. It only cares about the resulting tree structure and positions. 5. Different components at the same position reset state. If you replace a component with a different type of component at the same position, React removes the old one and creates a new one. When this happens, the old component's state is destroyed, and the new component starts with its own fresh state. Even if the markup looks similar, React sees this as a completely different element because the type has changed. The same applies if you switch the wrapper elements around a component, say, from a section to a div. Because the structure of the tree changes, React resets everything below that point. In general, if you want to preserve state, make sure your render tree structure stays the same between renders. If the structure changes, React will reset the state because it interprets the change as removing one subtree and adding another. 6. Pitfall: don't nest component definitions. One subtle but important rule: never define a component function inside another component. If you do that, a new component function is created on every render, and React will treat it as a new component each time. That means it will reset its state every time the parent re-renders, leading to disappearing input values or lost data. To avoid that, always define component functions at the top level, outside of other components. 7. Resetting state at the same position. By default, React preserves a component's state while it stays at the same position. This is usually what you want. But sometimes you want to reset the state manually, for instance, when switching between two players in a simple scoreboard app. If both players' counters appear in the same position, React sees them as the same component and preserves the state. But conceptually, these should be two different counters, one for each player. There are two ways to make React reset the state in this case. Render the components in different positions. Give each component a unique key. 7.1 Option 1. Rendering in different positions. You can render each component in its own distinct place in the tree, for example, by using two conditional blocks. When one is visible, the other is not. Switching between them destroys the previous one and creates the other anew. Each time you toggle, React removes one component, clears its state, and mounts the other from scratch. This approach is simple and works well when you only have a small number of possible components. 7.2 Option 2. Resetting state with a key. The second, and more flexible, approach is to give each component an explicit key. You might be familiar with keys in lists, but keys can be used anywhere. They tell React how to distinguish between different instances of the same component type. By giving each player's counter its own key, say, one for Taylor and another for Sarah, React knows they are not the same component, even if they appear in the same spot in the tree. As a result, each counter maintains its own state identity, and switching between them resets the state rather than preserving it. Keys don't need to be globally unique, they only need to be unique within the same parent. 8. Resetting a form with a key. The same technique is especially useful in forms. Imagine a chat app where each conversation has its own text input. If you switch between contacts, the input text might stay the same, which could be dangerous, because you could accidentally send a message meant for one person to another. To fix that, you can give the chat component a key based on the contact's ID. That way, every time you switch to a different contact, React recreates the chat component and resets its internal state, including the input field. This ensures that the text box always starts empty when you switch to another person. 9. Deep dive. Preserving state for removed components. In a real-world chat application, you might want to go a step further and preserve the draft message even after switching contacts. There are several strategies to achieve this. Keep all chats rendered and simply hide the inactive ones with CSS. This preserves their local state but can become inefficient for large apps. Lift the state up. Store the draft messages in a parent component so they persist even when child components unmount. This is a common and efficient solution. Persist drafts externally, for example in local storage, so that drafts survive page reloads or app closures. In all these cases, it still makes sense to assign a key to each chat, since each conversation is conceptually distinct. 10. Recap. Let's summarize the key takeaways. React keeps a component's state as long as it remains in the same position in the render tree. State isn't tied to JSX tags, but to their position in the tree. You can reset a component's state by giving it a different key or rendering it in a different position. Avoid nesting component definitions inside others, or you'll reset state unintentionally. Understanding how React associates state with tree positions gives you much finer control over your components, letting you decide when to preserve state and when to start fresh.